Okay, folks, here we go. Chapter 1-2 continued from your book. Are we ready? Tonight's homework is 47 through 62 all, 69 and 70.
Why do you do that? Sometimes you talk like this.
I do.
Yeah, like you.
Does it annoy you?
No, but opposite. Or
69 and 70.
I don't know. You got your face going on today?
I do? How about the 50? I'll ask this is numbers first. Okay, now get your books open to page 26, please. Books open to page 26.
Yeah. 26.
I don't either.
Mrs. Yoder, I'm gonna be honest, you are really unfuzzy today.
I'm going to be honest with you, we're going to do something anyway.
You guys take a look at?
No. Okay, now, here we go, notes. Today, what are we talking about? We're talking about domains.
Whoa.
Yes, now we're talking about restrictions on domain. So, start writing. Domain, all the x values, all the values that x could take on which will make the statement true. Nice. I don't want to sing to my fellow 5th period people. Restrictions on domain. Obviously, we have a restriction on a domain whenever it's undefined. Meaning, if the variable x is in the numerator, then there are no restrictions. Because it's in the numerator. When do you have a restriction? When it's in the denominator. Yeah. Woo!
Are we your smallest class?
Well,
No, yeah, there's something.
maybe.
Naturally, there's one.
It is.
7, 8.
I think it's funny because your first period is bigger than last year.
No, 8 people.
My period last year and the first period is higher than ours.
I'm actually going to put this like that.
Can we check yours?
Go for it.
Yes.
Yes,
Bless
you
you.
can.
Are you that person on Facebook who always puts like 700 exclamation marks after everything? Could you just put 2 there and I just feel like that's you?
I speak it. Restrictions on domain. If variable x is in the numerator, then there are no restrictions, meaning x can be anything it absolutely wants. So what would you write here? You would write Neil. Or that. Because you've been sick. I'm not getting sick. Number 2, when the variable is in the denominator cannot equal 0. Well, why is that? Because when you divide by 0, it's not legal, right? Okay? 3, even radicals have to be greater than or equal 0. The junk underneath the radical has to be greater than or equal 0. Why, oh why, do I have number 3? Why does the junk underneath of an even root, a square root, a fourth root, a sixth root have to be greater than or equal to 0? Because can you take the square root of -9?
No.
No, because there is no number out there that whenever you multiply by itself will give you a negative outcome, correct? Okay, so an even root means you cannot have a negative underneath the square root, meaning it has to be greater than or equal to 0. An odd root, meaning a cube root, a fifth root, a seventh root, has no restrictions. Why, oh why, is there no restrictions on an odd root, but there is on an even root? Because a negative times a negative is a negative. So can I take the cube root of a negative number? Yes. Can I take the cube root of a positive number? Yes! 8 is 2 times 2 times 2. So 2 cubed is 8, right? Negative 8 is negative 2 times negative 2 times negative 2. Yes? So therefore, I can take the cube root of a positive number and I can take the cube root of a negative number. It doesn't matter what x is. Do we understand that, yes or no? So we have restrictions on even roots. We do not have restrictions on odd roots. So therefore, right now, when do we have restrictions? On an even root and when you have a variable in the denominator. Do we understand that, yes or no?
Yes.
Yeah.
Woo. Okay. Now, I'm going to show you this slide to make you understand what we just talked about. Square root of negative 4 is 2i, which is why that has to be an even root. It has to be greater than or equal to 0, right? We all understand that now. Also, the cube root of negative 8 is negative 2 times negative 2 times negative 2, which is negative 2 cubed, and the cube root of negative 2 cubed is going to be just negative 2, which means it's totally legal to take the cube root of a negative number. Green means go. Red means stop. Do we understand that? So the square root of a negative outcome is not illegal. Okay? Not in the real number system. It's legal in the imaginary number system, but we're in the real number system. Are we all good? Yay or nay? Okay. Moving swiftly along. Now, how do you move swiftly along? Have you never seen the Smurfs? La 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 la. I did record that. Those periods going to get a little.
Start that too.
Okay.
Here we go. Oh, we're on there.
It'll be just like a bear. Find the domain of the function. So 49 through 58. Now, I'm going to express to you that this is extremely, extremely, extremely important that you learn this. Okay? Domain is something I have taken time out to not give you this yesterday because it's so important that I needed your brain fresh to grasp this concept. Do you understand that? That's why I didn't cover this yesterday. I could have. But I needed your brains fresh to understand that this is the only thing you have to focus on today. All right? So number 49. 5x squared plus 2x minus 1. Do I have any restrictions on x? So number 1. Is x in the numerator? Yes. So far, are there any restrictions? No. Number 2. Is there an x in any denominator? No, because it's not a fraction. Number 3. Are there any square roots, fourth roots, or even roots? Are there any even roots, radicals? No. There's nothing radical about that problem. Which means number 4, is there any cube roots? No. So since there's nothing in here, you simply say x is an element of the reals. That element symbol is a C with a line in the middle, meaning a curved E. X tells you that you're taking a variable that is in f of x and saying that you're placing it into a number system. The number system I'm placing it into is going to be the real number system. We understand that. Meaning x can be any possible number in the world. Now, 51. Do I have any restrictions?
Yes.
Yes. What are they? The denominator, t, cannot be 0. Well, if it cannot be 0, what can it be? So what you're telling me is I need to put t into a number system. So t is an element of the reals, but, the comma, I have to write t cannot be 0. There's my domain. So I put it inside a number system, I have to put it into a family, and then I have to say the restrictions that are upon that family. Do we all understand that, yay or nay? 53, the cube root of x minus 4. Do I have a fraction? Do I have any even roots? Do I have any cube roots or odd roots? Yes. Are there restrictions on odd roots? No. So therefore, what's my answer? X is an element of the reals, meaning it can be any real number that it possibly can think of in the entire world. Do we understand this? Moving along. 53. God. Thank you so much. 55. Do I have restrictions?
2.
How many?
2.
Why 2?
Because there's 2 denominators.
Because there's 2 separate fractions with separate denominators. Implying you don't just have one and say, hey, I just like the first fraction, I'm going to forget about the second one. Not legal. You have to deal with both of them. So I have the first denominator of x, and that cannot be 0. And then I have my second denominator, x plus 2, and that cannot be 0. So if I solve this, what does that give me? So now I need to put it into what? Thingy. Let's name that thingy. I need to put it in a number family or number system, and that means x is an element of the reals, but x cannot be 0, and x cannot be negative 2. Are we getting it? That's great. So I'm not going to do any more, but I'm going to do an example of what I want to do. So let's say f of x is equal to 3 times the square root of x plus 2 all over 4x minus 7. I have what? Why do I have 2 restrictions? I have a fraction, which means my denominator cannot be what? So 4x minus 7 cannot be 0. And then I have, what's my next restriction? Then even root. The junk underneath that has to be what? That junk, x plus 2, has to be what? Greater than or equal to 0. Positive meaning greater than or equal to 0. Can it be 0? Yes, because can I take the square root of the 4th root of 0? 0 is neutral, it's either positive or negative. We understand that. Okay? So with that said, if I solve this thing, I have x is equal to 7/4, or not equal 7/4. What is that approximately? 1 3/4. Do we all see that? Nay? Now, go over here. X has to be greater than or equal to negative 2. Now you tell me, which one of these do I take? Sorry? By both? Well, in order for you to say both, you have to first ask yourself, if I put this on a number line, here's 0, here's negative 2, and I'm saying that it can be negative 2 or it can be above negative 2. You see that? Where's 1 3/4? 1 3/4 is right here. There's a hole in the graph there. I am not allowed to be that value. Do we understand that? It can be any value greater than negative 2, but the value of 1 3/4, which is 7/4, is within that range, in that domain region. And I have to pluck it out there and say, hey, it can't be that one, though. So how do I write that? X is an element of the reals. X is greater than or equal to negative 2. And x cannot be 7/4. You can understand that, yes or no? We're good? Now, this domain can get tricky and ugly, and I guarantee whenever I give you a test or a quiz over this, you're going to be like, what? Oh, that was ugly. Yeah, I'm going to give you the nastiest little thing I can possibly think of. I might have a square root in there, a fraction, and then something nastier than that. Do we all understand that? Okay. I know, aren't I nice? I'm just here to be a blessing any way that I can. Okay, what about this? What about this one? This one takes you way back to Algebra 2.
Factor x out.
I have to factor out an x. Because if I factor out an x, I'm going to get x minus 2. Correct? Yes? So that means x cannot be 0, and x minus 2 cannot be 0. Now, if we were to look at this thing graphically, anybody know what it would look like? Hold on, please. I want to make sure I'm getting through all before I go on a tangent here, so let's make sure. Okay, I think that's about all, except for range. Range are all the values that y can take on. You're going to read this from the bottom to the top of the graph. Now, I'm kind of picky about this, because I want you guys to be able to read a graph algebraically and look and find a domain algebraically and find it graphically. So whenever you're looking at a graph, and I have this lovely little graph y is equal to the square root of 4 minus x squared, what we're going to do is you guys need to make sure you always have your calculators up, because whenever I'm working on mine, you guys need to get used to them. So please grab your calculators very quickly. Quicker. Faster. A bit. Yep, a little bit more. Faster. I am very bossy and pushy. You guys wouldn't know what to do if I wasn't, though.
Just that.
Just no, you don't have to log in.
Wrong class.
Good songs.
The x was 1 minus x squared.
Okay, so I'm going to go ahead and I'm going to add a graphs page here. And this is going to be control x squared to be the square root. And that is going to be 4 minus x squared. And I hit enter, and this is what I get. It's right there.
I don't know how to do that.
How do I do that? You type in second x squared. There. Now the break. Please use that. Get off the scratch pad. I said a new document.
Why didn't you like this? So working.
Okay, type it in. 4 minus x squared. Now, this is my lovely little picture here. And what I want you to do is I want you to read this thing from left to right graphically. From left to right graphically is the way you read your domain. So at what value do you think it starts? I'm chugging along over here at negative infinity, right? And I come to negative infinity and I get closer and closer to the x-axis. Where do I start touching the graph? It looks like I start touching the graph at -2. Well, how can I determine that? If I hit menu and trace and graph trace and hit -2, do you see I have this nice little asterisk looking thing? And it says, hey, right down here on F1, I'm at the value -2, 0. Meaning there is a specific point on that graph at -2, 0. Okay? Which means now if I chug along and I go to -1, guess what? At the value of -1, I have a y value of 1.73. So do I still have a coordinating y value to my x value?
How do you move it?
Answer the question I asked, folks. Look at me and pay attention. Domain exists when there is a y coordinate to match the x coordinate that you are with, or you are evaluating that. You understand that? So my question to you, whenever I did, let's say -5, do you see that line? What does it say over here? Undefined meaning, is there a coordinating y value to that? No. So is that part of my domain? No. But as I go over to -2, guess what happens? It pops onto the graph. If I keep going at -1, guess what? It's still on the graph. If I come over to 2, guess what? It's still on the graph. If I go to 2.5, what happens? It falls off the graph. So can you tell me what the domain of this thing is graphically? From -2 to 2. Can it be -2? Can it be 2? Yes. Do we understand how to read graphically the domain? Yes or no? Now, how do I read the range? Well, we read domain graphically from left to right. So how do I read range? From the bottom, because that's the lowest y value you can have, to the top, meaning the highest y value you can have. Yes, no? So the question is as I'm going from my y, where do I first run into my lovely little x value? I run into it at the lovely little x-axis. Do we understand that? Which means what y value is that when I'm running into the x-axis? 0. So at 0, you can clearly see that I start to run it in. And where do I top out at? See, do you see this? I'm showing you that that's my range. It's starting at the value 0 and it's ending at the value -2. Well, how do I make sure that that's a true statement? All I have to do is hit Menu, Trace, Graph Trace, and on 0, what value is y? 2. That's as high as it gets, correct? So if I go back to my lovely little graph, or my paper, what do I write on here? Well, my domain is going to be bracket -2 to 2. If you don't like to write it like that, well then write it like this. -2 is less than or equal to x, which is less than or equal to +2. Meaning x is trapped between those two values of -2 to 2. It can't get out. There are no x values that have a coordinating y value below -2 and above +2. Do we get that, yes or no? Now, how do I write my range? 0 to 2. Or 0 is less than or equal to y, which is less than or equal to 2. Why did I put a y in there? Because it's the range, and the range deals with the y values. Do we understand that? Okay, well now let's look at this one right here. The absolute value of x minus 2. Well, if I graph this thing, what does this thing look like before you graph it? Way back to Algebra 2 translations. The absolute value of x looks like what type of a graph? It looks like a V. So if I have x minus 2, what happens to the graph? Nope, it's not down. Nope, it's not up. It's inside the bars. So when it's inside the bars, we have a translation that's going to move this thing not -2, meaning we think to the left, but to the right 2 units. So if I graph this thing, and I'm going to Control Dock and get a new graph, and I'm going to go ahead and type in, hitting the key to the right, 9. There's my ABS. I'm going to type in x minus 2 and hit enter. Do you see it move that thing to the right 2 units? So my question to you is, how do I read that domain graphically? I'm coming over here all the way back by negative infinity. Is there a corresponding y value at negative infinity? Is there? Well, what happens to this v? You only see this, but where is it actually shooting out to? up to the ceiling, out to the sky, clear out in space, and what happens to the arms when it's clear out in space? It gets wider and wider and wider, right? Okay? Which means clear out in space, I actually do have a corresponding y value. We see that this whole time. I don't know why I'm thinking that, but okay? So we see that there are corresponding y values there. Which means, what is my domain of this thing? Any number, because there's no restrictions. When I clear out negative infinity, I have a corresponding y. When I clear out positive infinity, I have a corresponding y. Do we understand that that's the domain? Now, what is the range? Now, I changed my scaling by accident. So I'm going to hit Control Z so that it just looks prettier. Okay? Now, you tell me, we know that x minus 2, the absolute value, that has been shifted to the right to the unit. So you tell me, what is my lowest y value? The first y value, when I'm chugging along from negative infinity down at the bottom of the y-axis, I'm chugging up on the y-axis, the first y value I come to is going to be 0. And what's my largest y value? Infinity, meaning there is no end to it. Do we understand that? Yes or no? Excellent. Now, with that said, the domain here, what did we say this was? I'm sorry? X is an element of the reals. You're absolutely right. Because x can be any value. Whenever you read it graph from left to right, it can be any value it wants to be. Now, what's the range on this thing? It starts out at 0 and it goes all the way up to infinity. Now, the bracket means that you're including it. The parenthesis means you're not including it. Why can I not put a bracket on infinity? Because I can always tack on another number on it, right? And make it bigger and bigger and bigger. Now, that's one way of writing it. Or I can say 0, y is going to be greater than or equal to 0. Meaning it can be any number as long as it's greater than what value? 0. Do we understand that? Yes or no? Okay, so if you're looking at tonight's homework, you have 47 through 62. Are there any questions on 47 through 58? It's finding the domain restrictions.
On the first two, are you setting an equal to each other?
Huh?
47, 48. I don't know what it's asking for.
On problems 47 and 48, it says find the values of x for which f of x equals g of x. Yes, set them equal to each other and solve. Okay. Now, 59 through 62, it says if you're graphing utility to graph the function, find the domain and the range of the function. Now, I want you to do that graphically. Do we understand that? So if you don't have a graphing calculator, you need to take the last few minutes here in class and do those problems first so that you get it done before you leave. Any questions over what I just said?
Wait, which one? The last two?
59 through 62. Any questions? We good? Yay!